Okay, so this is Chantel talking about solving equations with one radical expression. This is the second half of section 1.4 in the college algebra textbook. We're only covering 3 pages. This is a lot of information and takes a lot of practice. So again, I'm going to be doing many examples. All right, so if you have a radical expression, that means that you have a radical, that thingy-mabob right there, the square root sign, but it can also be cube root or whatever, but generally we're going to be looking at square roots. So what you want to do first is get the radical on one side by itself and then square both sides to eliminate the radical. So remember, if you square a square root, it cancels it out. Basically, it goes away because they are inverse of one another. So in this first example, what we're going to do is just simply, it is already by itself, so we're going to square it and we're going to square the other side as well. So square both sides. So when you square a square root, the radical sign goes away and we're just left with x plus 2. If you don't remember this, go look in the review section, the section about radicals. All right, 6 squared is 36. Now we are going to subtract from each side. We're going to subtract 2 from each side and we get x equals 34. And it is that simple. All right, so none of them are really going to be that simple though, because generally there's a lot more to an equation than that. So I'm going to take this and scoot it up just a little bit, give us a little more room. So remember that the first step was to isolate the radical so that it's all by itself on one side, if there's only one of them. And so we're starting with that. So we're going to subtract 4 from both sides, and we're going to get x squared minus 5x under the radical sign equals 6. Now we're going to square both sides. And we're going to get x squared minus 5x. So whatever is under the radical sign, which is just this whole thing right here, is going to now just have no radical because the x squared and the square root canceled. And that's going to be 36. So now this time we end up with a quadratic equation. We need to bring the 36 over here so that it's equal to 0, because that's how we solve quadratic equations. So x squared minus 5x minus 36 equals 0. All right, so we've got x and x equals 0, and we end up, they need to have a minus and a plus. And we're going to get, the minus is going to be, if you play around with this a bit, you'll find the minus is a 9 and the plus is a 4. If you don't know why, stop the video here and take a look at that and figure it out. You need to get good at factoring if you're not already. So we've got x minus 9 equals 0 and x plus 4 equals 0. So x equals 9 and x equals negative 4. Okay, and so if you check this, I am going to show you the check on this one because I want you to really be practicing checking, because here's where you're going to start seeing some things that don't check out. If you have, let's try the 9 first. All right, so we're going to have a square root plus 4 equals 10, and I'm going to replace every x with a 9. Okay, so minus 5. All right, so we're going to make the 9s all in red. I'm just doing 9 right here, and 5 times 9. Okay, so I put 9 in everywhere there was an x. So I get 81 minus 45 plus 4 equals 10. 81 minus 45 is 36. Square root of 36 is 6. 6 plus 4 is equal to 10. So that one checks. The next one is going to be negative 4. So I'm going to do this in color for you again. So it's going to be squared, it's going to be times 5, and then plus 4 equals 10. So we need to see if that actually makes it true. So I'm going to put in a negative 4 here. And remember, the negative 4 needs to be squared, the whole thing. So I put it in parentheses so you don't forget that you square the negative as well. And then 5 times negative 4. All right, so just going to take that and multiply it and add it all together. And we get negative 4 squared is 16 plus 20 plus 4 equals 10. 16 plus 20 is 36. Square root of 36 is 6. Plus 4 is 10. and that is true. Okay, so both of those turned out to be true. All right, so moving on to the next one. This is just for you to do, so I'm going to give you guys a chance to do the check it out. So take a moment and solve this one, and don't forget to check it. Okay, so to save time, I went ahead and worked it all out and just wanted to point a few things out to you. Remember to get the square root of 4x plus 5 by itself. So you need to add 1 to both sides to start with. Then you're going to square both sides. The 4 here canceled out. It was on both sides, so I was able to cross it out. It subtracts out if you say minus 4x on both sides. So you end up with x squared equals 1. Which means you have two solutions, either 1 or -1. And then don't forget to check. So over here on the right, I did a check, and I found that both of those solutions are correct. All right, so I'm going to move on to solving equations with two radical expressions. So this is more complicated, but it just means you do it twice, and it's not any more difficult. You just have to be careful. So the first step is to isolate one of the two radicals. And then you are going to square both sides to eliminate one radical, and then you're going to combine like terms. If you still have a radical, which you will have a radical, you're going to repeat steps 1 to 3. Once in a while you might have a certain situation that causes the radical to go away, but in most cases you won't. Okay, so the first thing I'm going to do is have the one on the left by itself, so I'm going to subtract the square root of x minus 5 from both sides. And I meant to do blue, so I'll switch. So it's going to go away here. Subtracts out, and I end up with the square root of x plus 3 equals 4 minus the square root of x minus 5. All right, so now I'm going to square both sides. And as you can see, I'm going to get something a little more complicated on the right side. So on the left, I get x plus 3. Because the square root squared makes it go away. Squaring a square root goes away. So they're inverses of one another once again. Now in this one we're going to have to use FOIL. So it's going to be 4 minus square root of x minus 5 times 4 minus square root of x minus 5. So you're going to use one of the special products rules. And so we're going to square the first one. That's 16. And then we multiply them together with a minus because there's a minus there. So 4 times square root of x minus 5 plus 4 minus square root of x minus 5, that means we just double it. So it's 8 minus the square root of x minus 5. All right, so this is, that's a times right there, sorry. So 8 times the square root of x minus 5. And then we're going to take x minus 5 with a square root squared. So that's going to give us x minus 5. So when it's a negative times a negative, so remember it becomes positive, and we get x minus 5. So we're just using the rules from the special products. In other words, we're taking 4 minus the square root of x minus 5 times 4 minus the square root of x minus 5. Okay, so you can do it that way if you'd like and just FOIL it, but I like using the special products because I have it in my head at this point after using it for so long. All right, so I'm going to erase that so that I have space to check later. All right, let's see. So now we just need to get everything on one side except for the radical. So we still have a radical, the square root of x minus 5. And if you work all of this out, you can get, let's see. So I'm going to end up with 8 square root of x minus 5 on one side. And you want to get it by itself. And then if you combine all the other terms, you're going to see that this x subtracts out right here. And then you combine the constant terms, and you get 6 minus 5, and then bring this 3 over to the other side. So that's minus 3. You're going to get 8. So divide both sides by 8, and the 8 goes away, and that gives you 1. So we end up with the square root of x minus 5 equals 1. All right, so now we need to do it again. So steps 1 through 3 again, and it becomes much simpler though. And we get x minus 5 equals 1 squared is 1. And that means, I'm going to lower this down here, that means that x, we add 5 to both sides, equals 6. Okay, so checking that is actually really easy. You just say the square root of 6 plus 3 plus the square root of 6 minus 5. I'm just putting 6 in everywhere I see an x equals 4. So square root of 9 plus the square root of 1 equals 4. And that's 3 plus 1 equals 4. And that is true. So this was our check. Okay. All right, so that is my first example of two radicals. It does get a little more complicated than that, but not too bad. It's just a matter of sticking with it and doing it twice. So here's an example of two on the same side. Remember, we want it on the same side, one of them by itself. So I'm going to move this over to the other side by adding it. So I get the square root of x minus 1, and if I add this to the other side, it goes away on the left and it ends up as 3 plus the square root of 2x minus 1. Now I'm going to square both sides, and I get x minus 1 on the left equals, now I'm going to use a special product, but it has a plus in the middle this time instead of a minus, so I square the first one, plus, I multiply them together and then multiply by 2. So 3 times the square root of 2x minus 1 times 2 is 6. 2x minus 1. Look at the special products. Go back to that section if you need to. Plus, now square root of 2x minus 1 squared is 2x minus 1. Okay. So I've got to combine and subtract things out. So I've got a minus 1 on the left. I've got a minus 1 on the right, so I'm going to cancel those out. I want the 6 times 2x minus 1 by itself on one side, so I'm going to bring everything else to the other side, and I get x plus 9. Okay, so I subtracted the 9 from both sides. Actually, what I did was I subtracted the 6 square root of 2x minus 1 from both sides, and I end up with it on the left with a negative. You could do it the other way and make the x plus 9 all negative as well. But this was easier because I ended up with a negative 6 square root of 2x minus 1, and then I'm going to have x plus 9 on the right, and then I'm going to square it. And what happens to the negative here? Well, when you square a negative, it goes away. So you end up with 36. And then 2x minus 1 square root squared is just 2x minus 1. And then on the right, I get x squared plus 18x plus 81. And if you don't know how to expand a binomial squared, you need to stop and look at that and practice on your own. It's something you need to, again, get really good at. All right, so we're going to distribute this, and we get 72x minus 36 equals x squared plus 18x plus 81. All right, so combining all of these together, I'm going to bring everything to the right side, and it ends up being x squared minus 54x. So when you subtract 72x from both sides, you get minus 54x. Add 36 to both sides, and you get plus 117 equals 0. All right, so this was not easily factorable, so maybe you can come up with something really quick, but I just used the quadratic equation, and I end up with 54 plus or minus the square root. So remember, a is 1, b is negative 54, and c is 117. So I get 54, negative 54 squared minus 4 times 1 times 117. All over 2. And this, after you simplify it, is 54 plus or minus the square root of 2448. And on the bottom, you get a 2. So you could stop here and put that in your calculator. Two different ways. You're going to put 54 plus the square root of 2448 over 2, and then you're going to put 54 minus the square root of 2448 over 2. I recommend that you do that right now. Stop and do it and make sure you're getting the same answer that I'm getting. I have a lot of people have a hard time using calculators properly. So go ahead and try that. And then what you should get in your calculator, when you subtract the number under the radical, you'll get 2.26. And when you add it, you should get 51.74. Okay? So those are your two choices. If you were going to reduce this, if you were supposed to leave it in this format, you're going to get that 2448 is 36 times 68, and 68 breaks down to 4 times 17, so that's 36. Remember to look for perfect squares, and that's where knowing your perfect squares or having them written down and sitting right in front of you while you're working really helps. So look for those factors in a number, and you end up with 36 is a perfect square and 4 is a perfect square. So both of those come out as 6 times 2. So you end up with 12 out front and 17 under the radical sign over 2. And then that reduces because there's a 2 in both of these numbers that you factor out, and you end up with 27 plus or minus 6 square root of 17. Okay, so that's your answer. Or if they want decimals, that's your answer. And you need to be competent in both. So practice both. All right. So I just wanted to explain this answer to you because as it turns out, this one is one that doesn't check. It doesn't work. And one of the reasons I wanted you to continue on until we had the decimals so that you could plug it in back into the formula. If you plug both of those numbers back in to the original formula, so 2.26 for x, you don't get the right answers at all. For the first one, if you plug 2.26 in, you're going to get, so for 2.26, you're going to get an answer of negative 0.7537 equals 3. And it does not equal 3. So 2.26 doesn't check out. Then when you go to check out 51.74, you plug it in to your calculator and you find that you get, let's see, basically negative 3. It rounds to negative 3 equals 3. And that isn't true. So these do not check. There is no root or no solution to this. So that's why the quadratic equation does not always work. You'll get a number and sometimes it actually doesn't exist. So that's not a solution. So if you look at the graph of this, you'll see here that it's a little bit bigger, that it doesn't ever cross the x-axis. It's this really strange shaped graph that never crosses. So this one has no real solutions. So the solution does not exist, D and E, if you're answering on X, Y, Z. Okay, so at this point, I would like you to try check it out 7. You do need to check this one. That's my hint. So you're going to get a couple answers, and you need to check them both. All right, so I can't wait to see what everybody gets on this one. Okay, so here is the answer, and you can look through everything in blue there and get down to see where I got 13 and 1. But when you check them, 13 does not check out, 1 does, so x equals 1 is the only correct answer. And I would encourage you to go graph this in Desmos and see what you see there, and see if that actually checks out, that x equals 1 is the only place where it touches the x-axis. Okay, once in a while you're going to see one that has a cube. These are going to be pretty simple because they're not going to throw too much at you with these. I just want you to see how to do them. If it's cubed, the way to get rid of a cube, me do this in blue, is to get rid of a cube root is to cube it. So you're going to cube both sides like that, and you end up with 5x minus 3 equals 5 times 5 times 5 is 125. So I end up with 5x equals 128. Divide both sides by 5, and I get x equals 128 over 5. And that is your only answer. And if you check that, just for the sake of time, I'm not going to, but if you check that, plug it in for x, you're going to see that you get the cube root of 125, which is 5. All right, so I have one more thing to show you, and that's an application of this that's kind of interesting. This is a problem that comes up a lot in different situations, and I've seen it on tests and SATs and things like that. So this is a great problem. Sorry, I'm trying to move this around just a little bit to be able to see it better. So two painters are available to paint a room, and working alone, the first painter can paint a room in 5 hours. So if he can paint a room in 5 hours, that means that this painter can, in 1 hour, he or she paints 1/5 of the room. Okay, so if the first painter paints 1/5 of the room in an hour, and then the second painter can paint the room in 4 hours working by herself. So that means in 1 hour, she can paint 1/4 of the room. If they work together, they can paint the room in t hours. In other words, in 1 hour, they can paint 1/t of the room, 1/10, I guess, of the room. So that's what the equation is going to end up looking like, because, and it explains it in the problem just a little bit if you want to stop and read it. So it wants to know what t is. You're supposed to find the time it takes for both painters to paint the room together. So that is how you set this up. And from there, everybody's, I think, knows how to do this at this point. You're going to multiply both sides by the least common denominator, which is 4 times 5 times t, or 20t. So you can say 20t, or you can say 4 times 5 times t. It doesn't matter. And you're going to end up distributing it across both of these. And when you multiply 20t times 1/5, you should get 4t. And when you multiply 20t times 1/4, you're going to get 5t. And then when you multiply it over here on the right, the t's are going to divide out and you get 20. So you end up with 9t. The math of this is actually pretty simple. Equals 20. Divide both sides by 9. And you get t equals 20/9. Or another way to say that is 2 2/9 of an hour, or hours, I guess, hours, which is also, you can also say 2.22 hours, and you can also say 2 hours and 13 minutes if you work it out. You find that it's 2 hours and 13 minutes. Okay, so that's how you do one of the word problems, and there's not many word problems in this section. All right, see you in class.